Hello friends, this is third lecture according to surface tension, and today we are discuss about the shape of liquid drops on a solid surface. That is very important concept. Now generally when any type of drop is dropped on the plane solid surface, it will be directly spread on the solid surface, otherwise it will generally spherical. It is depends upon the nature of liquid, which type of liquid we are drop on the solid surface. Now let's imagine that this is a drop, and which is liquid drop and drop on the solid surface. When it will be drop on the solid surface, so now there are liquid and solid both are contacting together, and as same as the air and liquid and air and solid is also contacting together. Now here T1, T2 and T3 are indicates that the force due to surface tension between different pairs. Now here T1 indicates that the force due to surface tension between solid and liquid interface. Now T2 indicates that the force due to surface tension between air and solid interface, and T3 indicates that the force due to surface tension between air and liquid interface. Let's see here. So T1, T2 and T3. So T1 indicates force due to surface tension between liquid and air solid interface. Now T2 indicates that the force due to surface tension between air and solid interface, and T3 indicates that the force due to surface tension between air and liquid interface. Get it clear? Now according to the equilibrium condition, let's see here. Imagine that this is a plain solid surface, and on the solid surface just we are take a drop of liquid. So imagine that this is a drop of liquid. Get it clear? So now here this is T1, this is T2, and this is a tangent, and this tangent will be denoted by T3. You get it clear? This tangent is making an angle that is called theta inside the liquid. This is angle of contact. So now according to the equilibrium condition of drop, if the drop in equilibrium position, now the force on the left hand side and right hand side, both forces are same, both forces are equal. Get it clear? And this T3 is the force due to surface tension. Force due to surface tension, it means it is a force. So according to the concept of vectors, this force is resolved mutually to perpendicular components. Okay, this force T3 is resolved mutually to perpendicular components. So this is the vertical component of the force, and this is the horizontal component of the force. So this vertical component of the force will be denoted by T3 sin theta. You know, vertical component will be denoted by T3, okay, and horizontal component will be denoted by T3 cos theta. You know that. But now according to the equilibrium condition, we know that the drop becomes stable. So it means that the total force experienced on right side and the total force experienced on left side, it will be exactly same. The force due to surface tension between two sides are equal and opposite. So the total force experienced on left side, that is T2, this T2 is equal to this is T1 and plus this is T3 cos theta. So according to equilibrium condition, we get T2 is equal to T1 plus T3 cos theta. Now this T1 take before the equal sign, so we get T2, and this is minus T1 here. This is equal to what is remaining? T3 cos theta. Okay, and with the help of this, finally we find out the value of cos theta. So cos theta is equal to what we get? Equal to now T2 minus T1 divided by T3. This is very important formula according to the shape of liquid drops. Now cos theta is equal to T2 minus T1 divided by T3, and with the help of this formula we are trying to solve the different types of cases as according to the concept of angle of contact. So let's try to discuss the different cases about angle of contact. Can I rub this? Cases. Different cases. The formula is, you remember this, cos theta is equal to T2 minus T1 divided by T3. Okay, by using this we find out the different cases, and you remember all the diagrams. Okay, so where is the direction of T1, T2, what is meant by T1, T2 and T3, all that. Now the first case, first important case, if T2 is greater than T1, okay, if T2 is greater than T1, imagine that, and the value of T2 minus T1 is less than T3. Okay, this is the first case. What happens if T2 is greater than T1 and T2 minus T1 is less than T3? You remember that. Let's observe here. Imagine that the value of T2 is 5. Okay, the value of T2 is 5. So what is the value of T1? Because T2 is greater than T1. So definitely it is 4, 3, 81. Okay, so imagine that this is 3. You got it clear? It is 3. So now this is equal to we get 2. Let's observe here. T2 is greater than T1. So T2, this is the value of T2, this is the value of T1, and T2 is greater than T1. So and T2 minus T1 is less than T3. So this is T2 minus T1, that is 2, and this value 2 is less than T3. You got it clear? It means that cos theta is equal to T2 minus T1 is 2 and T3 is what about T3? Now T2 minus T1 is less than T3, so it means here definitely 3, 4, 5, anyone, because T2 minus T1 is less than T3, so T3 will be higher, T3 will be greater. You get it clear? So what is the result? So cos theta is equal to 0.3618, near about 0.66. Okay, 0.66, and the value will be positive, theta will be positive. It means if T2 is greater than T1 and T2 minus T1 is less than T3, then cos theta is positive. Okay, then cos theta is positive, and if the cos theta is positive, the angle of contact is acute. Okay, the angle of contact is acute. Let's observe here. We know that this is positive x, this is negative x, this is positive y, and this is negative y. What is the value of cos 0? Cos 0 is equal to 1, and cos 90 is equal to 0. You get it clear? So the value of cos theta is 0.66. It means 0.6 will be here. You get it clear? Cos theta, theta is present in first quadrant. So it means that the angle of contact will be acute. You get it clear? If T2 is greater than T1 and T2 minus T1 is less than T3, so cos theta is positive and the angle of contact is acute. This is first case. You get it clear? Now let's observe the second case. Second case, if T2 is smaller than T1, okay, T2 is smaller than T1 and T2 minus T1 is less than T3. So what are given? Let's see. Let's see here. The case will be exactly opposite. Now T2 is less than T1. So it means T1 is 5. Okay, T1 is 5 and T2 will be 3. Opposite. Okay, T2 is smaller than T1 and T2 minus T1 is less than T3. So T2 minus T1, 3 minus 5, that is minus 2. Okay, so therefore cos theta is equal to T2 minus T1 divided by T3, but T3 will be higher. T2 minus T1 is less than T3, so it means it is 3. So we get cos theta is equal to minus 0.66. What it means? It means cos theta is negative. Cos theta is negative, it means what? It means theta is present in second quadrant. It means what? The angle of contact is obtuse. Okay, angle of contact is obtuse. If T2 is less than T1 and T2 minus T1 is less than T3, cos theta is negative and the angle of contact theta is obtuse. Get it clear? This is our second concept. Now let's observe the third concept. Third case, if T2 minus T1 is equal to T3. So what are given? If T2 minus T1 is equal to T3. So T2 minus T1 is minus 2. Okay. Cos theta is equal to T2 minus T1 divided by T3. This is the equation. Now T2 minus T1 is minus 2. And this is exactly equal to T3, means T3 is also minus 2. So it will be cancelled and the answer is positive 1. It means the value of cos theta is equal to 1. If T2 minus T1 is equal to T3, then cos theta is equal to 1. And when cos theta is equal to 1, so we know that if theta is 0. Okay, if cos theta is 0, so you remember the same, cos 0 is equal to 1. You get it clear? So cos theta is equal to 1, so it means theta is 0. So this is the angle of contact about 0 degree. So this is the case about angle of contact 0. This is obtuse angle of contact and this is acute angle of contact. One another case will be remaining. Okay, that is fourth case. Fourth case, if now T2 minus T1 is greater than T3. Okay, T2 minus T1 is greater than T3. So what happened when T2 minus T1 is greater than T3? Let's see here. Now T2 minus T1, imagine that 2. T2 minus T1 is, imagine that 2. Otherwise, imagine that 5. Okay, T2 minus T1 is 5. Their subtraction is already 5. And T2 minus T1 is greater than T3. So T3 will be smaller. T3 will be smaller. And if we finding the answer, so definitely answer is 1 plus. Okay, the answer is 1 plus. And you are remember that if we are discussed about the different values of cos 0 is equal to 1, cos 90 is equal to 0, cos 180 is equal to minus 1 and cos 270 is equal to 0. It means the value of cos is lies between positive 1 to negative 1. Okay. So plus 1 value will be impossible. So that's why the fourth case will be impossible case. So these three cases are very important, about acute angle of contact, about obtuse angle of contact and about zero angle of contact. So get it clear? Okay. Now the next point from this chapter, the factors affecting on angle of contact. But then before, can I rub this? Okay. So note down all the concepts and let's discuss the next concept. So I can rub this, all that. The next concept is the factors affecting on angle of contact. The factors affecting on angle of contact. Factors affecting on angle of contact. Okay, in which factors they produces effect on the angle of contact. You know that when the solid is contact with liquid and liquid is kerosene, oily liquid, what about angle of contact? So angle of contact is acute. When the solid is contact with mercury, mercury is one another type of liquid, so angle of contact is obtuse. And when the solid is contact with pure water, so the angle of contact will be 0. It means angle of contact is depends upon the nature of liquid. If the nature of liquid will be changed, so angle of contact is also changed. So according to this, we get the first important factor about angle of contact. Let's see the first factor, the angle of contact. The angle of contact is depends on nature of liquid and solid in contact. Okay, so angle of contact is depends upon the nature of liquid and solid in contact. If the nature of liquid will be changed, so definitely the angle of angle of contact will be changed. So this is first effect on the angle of contact. Let's observe the second effect of angle of contact. Angle of contact depends on adding some amount of impurities. It means that angle of contact depends upon impurities. Okay, if some amount of suitable impurity or unsuitable impurity, any type of impurity is added with the liquid, now their angle of contact is also changed. So it means angle of contact depends upon the adding of impurity. And number third, it depends on the temperature. It depends on the temperature. If the temperature changes, the angle of contact is also changes. So angle of contact mainly depends upon that three factors. Number first factor, the angle of contact depends upon the nature of liquid and solid in contact. Number second important factor, the angle of contact depends upon the adding of impurities. And number third, the angle of contact depends upon the increasing temperature. You get it clear? So it means it depends upon the liquid, nature of liquid, it depends upon impurity, and it depends upon temperature. Get it clear? So after that we have discussed the total effects of impurities. When the impurity will be adding, what happen about angle of contact, and then after we have discussed the effect of temperature, what happen when the temperature will be changes. Now the next concept for this chapter will be the effect of impurities and effect of temperature. So we have discussed simultaneously one by one. So initially we have discussed the effect of impurities. Okay, initially we have discussed the effect of impurities. The effect of impurities. Effect of impurities on angle of contact. There are three different concepts according to the effect of impurities. I can just explain. If imagine that the total soluble impurity, okay, imagine that the completely soluble impurity is added with pure water, like a common salt. If common salt is directly added with pure water, we know that it is completely dissolved between the water. If that type impurity is added with water, now their surface tension will be increases. You got it clear? The angle of contact or the surface tension will be changes if the impurity will be added. If the total soluble impurity is added with pure water, now their surface tension of the water will be increases. Now after that, if imagine that the sparingly soluble impurity is added with pure water, what happen when the sparingly soluble impurity added with pure water? Sparingly soluble impurity means like a detergent powder is added with water. Imagine that the alcohol is added with pure water. Now alcohol, detergent powder, it cannot completely dissolve between the water. It is sparingly soluble impurity between the water. And if the sparingly soluble impurity is added with pure water, now the surface tension of the water will be decreases. That is very important. And if imagine that the insoluble impurity is added with pure water, insoluble impurity, like imagine that the solid material, okay, hard material, and it will directly take on the liquid. So definitely we know that it is undissolved for the liquid. If insoluble impurity is dissolved between the liquid, now their surface tension is also decreases. Only and only if the completely soluble impurity is added with pure water, their surface tension will be increases. Otherwise, sparingly soluble and insoluble impurities are added with pure water, their surface tension will be decreases. This is the effect of impurities on the surface tension. Get it clear? Number second, the effect of temperature. Okay, number second, the effect of temperature. The effect of temperature. The effect of temperature on surface tension. Okay, now in most of the liquids, if the temperature increases for the given liquid, now their surface tension will be decreases. Okay, it is happening in most of the liquids. If the temperature increases, their surface tension will be decreases. But accepted molten copper and molten cadmium. You remember this? accepted molten copper and molten cadmium. In molten copper and molten cadmium, if the temperature increases, their surface tension is also increases. But other than all the liquids, if the temperature increases, their surface tension will be decreases. Let's imagine that it is a one type of liquid. Okay, it is one type of liquid and their temperature will be increases. When the amount of temperature increases by the given liquid, their surface tension will be decreases step by step. When the amount of temperature increases step by step, now the step by step the surface tension will be decreases. The how many amount of, let's remember that is very important concept. So how many amount of temperature is given by that liquid, their total surface tension decreases and it becomes 0. So such amount of temperature is called critical temperature. Okay, such amount of temperature is called critical temperature. This is important definition. Which temperature is called critical temperature? In most of the liquids we know that when the temperature increases, their surface tension decreases. When again and again temperature increases, now their step by step the surface tension will be decreases. So how amount of temperature is required by that liquid, their total surface tension will be decreases and it becomes 0. So such amount of temperature is called critical temperature. That is very important definition. Get it clear? Okay, so these are the effects of impurities and effect of temperature on the surface tension. Now next concept, the excess pressure across the free surface of liquid. Now there are three different shapes of liquid. Now here the free surface of liquid is plane. Now here the free surface of liquid is concave and here the free surface of liquid is convex. Now what happens when the free surface of liquid is plane? What happens when the free surface of liquid is concave? And what happens when the free surface of liquid is convex? Now observe here, here the free surface of liquid will be convex. Okay. Let's discuss the same. In first, if the free surface of liquid is plane, the concept is very important. Now the force due to surface tension between two sides, okay, the force due to surface tension between two sides is equal and opposite. Get it clear? It means that there is no change in force due to surface tension between two sides. Now if the force due to surface tension between two sides are equal and opposite, it means the total pressure at the point of A and total pressure at the point of B is exactly similar. There is no pressure difference between the point A and B because the liquid will be equilibrium. So the surface will be plane. Liquid cannot moving vertically upward, cannot moving vertically downward. They moving here and they does not moving here. It means what? The force due to surface tension between two sides is equal and opposite, and the pressure at point A and B will be same. There is no pressure difference at the point of A and B. That is very important. Now after that, let's see the free surface of liquid is concave. If the free surface of liquid is concave, now their force due to surface tension is also vertically upward. Let's observe here, their force due to surface tension between two sides is vertically upward. If the force due to surface tension between two sides is vertically upward, it means very easy to know the resultant force is also vertically upward. Okay, the resultant force is also vertically upward. Now the total atmospheric pressure, okay, the total atmospheric, due to the atmospheric pressure, the total force experienced by the molecule A in downward direction. Get it clear? And according to the concave shape of the free surface of liquid, now there due to the resultant force, it is very easy to know that now the pressure inside the liquid will be decreases and pressure just above the concave surface will be increases. Get it clear? If the free surface of liquid is concave, the force due to surface tension between two sides is vertically upward. It means the resultant force is also vertically upward and pressure inside the liquid will be decreases and pressure just above the concave side will be increases. That is very important. Let's see the third concept. When the free surface of liquid is convex, this is the convex surface of liquid. When the free surface of liquid is convex, now let's observe the same. The force due to surface tension between two sides is vertically downward. Okay, the force due to surface tension between two sides is vertically downward and the resultant force is also vertically downward. The total pressure at the point of A and B. So we know that due to the atmospheric pressure at the point of A, the force due to surface tension is definitely in downward direction, and the resultant force is also vertically downward. It means the both forces will be adding together, and the total pressure inside the liquid will be increases, and outside the liquid the pressure will be decreases. So between all that two conclusions, it is very important to know that, let's see here between second case, the pressure inside the liquid will be decreases and pressure above the liquid will be increases. But here the pressure inside the liquid will be increases and pressure outside the liquid will be decreases. But between these two cases, it is very important to know that the pressure on the concave side is greater than the pressure on convex side. Let's say this is concave upward and in downward direction, that is convex. Now this is definitely convex, but this is also concave. Get it clear? It means that the pressure on the concave side is greater than the pressure on convex side. This is very important conclusion due to the free surface of liquid. Okay, due to the excess of pressure on the free surface of liquid. Remember that if the free surface of liquid is plane, the force due to surface tension between two sides is equal and opposite, and there is no pressure difference between two. The pressure at point A and the pressure at point B is exactly same. So PA is equal to PB. This is the first important condition. Second, if the free surface of liquid is concave, the force due to surface tension between two sides is vertically upward, and the pressure on the concave side is greater than the pressure on convex side. If the free surface of liquid is convex, the force due to surface tension between two sides is vertically downward. It means the resultant force is also vertically downward, and pressure on the concave side is greater than the pressure on convex side. Anytime the pressure on the concave side will be higher and the pressure on the convex side will be lower. And if the free surface of liquid is plane, there is no pressure difference just above the free surface of liquid and just below the free surface of liquid. So these conditions are very important, and by using this condition, okay, by using these three conditions, we are discuss next very important concept about this chapter. This is the expression for the formation of drop and bubble. This is very important concept according to this chapter. So let's start it. The expression for the formation of drop and bubble. Let's continue. But then before I can rub this expression for the formation of drop and bubble. Okay. So many times this is also called Laplace's law of spherical membrane. Okay. This is the expression for how to form the drop and bubble. Okay, and this is also called Laplace's law of spherical membrane. Okay, so let's discuss about the expression for the formation of drop and bubble. We know that generally the drop and bubble both are spherical. You get it clear? So I can draw the diagram of sphere. So initially we have discussed the formation of drop. Okay, and then after we have discussed about bubble. Get it clear? So let's imagine that this is a drop of water, this is a drop whose radius will be denoted by R. This is the center and whose radius will be denoted by R. R is the radius of the drop. Okay. The total pressure inside the drop is denoted by Pi. Pi is the inside pressure, and imagine that PO. So PO is the outside pressure of the drop. Get it clear? So we know that inside the drop the surface is concave, and outside the drop the surface will be convex. And for the previous condition we are already discussed about the total pressure on the concave side is greater than convex. Okay, so it means that the inside pressure of the drop will be higher and just outside the drop the pressure will be low. So it means that the total change in pressure will be denoted by Pi minus PO. Okay, their total change in pressure will be denoted by Pi minus PO. Such a change in pressure is called axis of pressure. Okay, this is called axis of pressure. If the inside pressure will be higher and outside pressure will be lower, so we know that if the inside pressure increases for the drop, now normally their radius will be changes because the inside pressure will be large. So that's why normally the radius will be changed. Let's see here what happens when their radius will be changed. Now we get their radius is normally changed. Their radius is normally changed. So initial radius of the drop will be r, small r. when the inside pressure will be high, now that's why they are due to the excess of pressure, their normally radius will be changed, and this change in radius will be denoted by delta r. So delta r is the change in radius, increasing radius. Okay, so definitely we get the final radius r plus delta r. So r is the initial radius. Okay, initial radius of drop. Okay, and r plus delta r is the final radius. Is the final radius of drop. You get it clear? So due to the excess of pressure, now initial radius will be small r, and if the inside pressure will be high, so their radius normally changes from r to r plus delta r. So what is their initial surface area of the drop? So initially we have find out the initial surface area of the drop, and then after we have find out the total surface area of the drop, final surface area of the drop, and then after we find out how amount of area will be changed when the excess of pressure produces. You get it clear? So what is the initial surface area? So now the initial surface area of the drop is, imagine that this initial surface area will be denoted by A1. You get it clear? The initial surface area A1 is equal to, what is the initial surface area? Their radius will be small r. It means initial surface area will be denoted by 4 pi r square. Okay, this is the initial surface area. Call this is our equation number 1. What is the final surface area? So imagine that their final surface area will be denoted by A2. So the final surface area is equal to, this is also spherical, so 4 pi, but radius will be changed. Here r square, now here r plus delta r. So radius will be changed. So this is whole bracket square. This is our final surface area. But now this final surface area we are given A2 is equal to 4 pi becomes same, and let expand this equation by using a plus b bracket square formula. Okay, what is the expansion? Now a square, it means r square plus 2r into delta r, 2ab plus b square means what? Delta r square. So multiply this bracket with 4 pi. So we get the final surface area. So therefore final surface area A2 is equal to 4 pi r square plus 4 2s are 8 pi r delta r, again plus 4 pi into delta r square. Get it clear? But now observe here, when the inside pressure changes, due to the excess of pressure, their normally radius will be changed, normally, infinitely changed, that is very small change, delta r. Okay, delta r indicates that the very small amount of radius will be changed. So can I write 4 pi delta r square? So delta r is the very small change. So delta r square, definitely the term will be neglected because it is impossible. Okay, it is infinitely change, very small change. So delta r square, it is impossible. So between this term, so 4 pi delta r square, these terms are neglected due to the very small amount of change of radius. Get it clear? So it means we get the final surface area A2, this is equal to 4 pi r square plus 8 pi r into delta r. Call this is equation number 1, which indicates the final surface area. So how amount of area will be changed? So let's find out the change in surface area. So change in surface area will be denoted by dA. So dA is called change in area. So this change in area is equal to the final area minus initial area. So this is called change in area. Let's put the different values. Now therefore the dA is equal to A2. A2 means what? A2 is the 4 pi r square plus 8 pi r into delta r. This is the value of A2 minus A1. What is the value of A1? So A1 is the 4 pi r square. So 4 pi r square. Between this positive 4 pi r square and negative 4 pi r square will be cancel, and we find out the total increasing area, that is change in area dA is equal to 8 pi r into delta r, call equation number 3rd. Okay, this is our equation number 3rd, and this equation number 3rd indicates that the total value of change in area. Get it clear? Now we know that if the sum amount of area will be changed, area will be increases. So work has to be done. Okay, so as per the definition of work done, we know that, let's we find out the work done. Can I rub this area? Okay, now okay, I can write here. Let's see. As per the definition of work done, we know that work done we are already discussed in the relationship between surface energy and surface tension, and there we find out the expression for work done, dW is equal to T into dA, you know, T into dA. This expression we are already find out the value of work done, dW is equal to T into dA. So we are also know the value of dA, so put the value of dA from this equation. So what we get? We get the work done. So work done dW is equal to T becomes same into dA. So dA is 8 pi r into delta r. So this is the total work done when the axis of pressure produces. So call equation number 4. This is our equation number 4. Get it clear? But as per the definition of work done, okay, this work done we find out as per the relationship between surface energy and surface tension. But as per the definition of work done, so we know that work is defined as dW is equal to force into displacement. Okay, so here displacement will be denoted by delta r. Now normal change will be denoted by delta r as per the definition. Now this F is called, it is not only force. Due to the excess of pressure, the force produces, so such type of force is called axis of force. You get it clear? So as per the definition of pressure, we know that the pressure is equal to normal force per unit area. You get it clear? So what is the value of force? So force is equal to pressure into area. So by using this, the value of pressure, force, therefore dW is equal to, now dW is equal to this force. Force means what? Force means axis of pressure, Pi minus Po, pressure into area. Area will be denoted by dA. Area we know that already. Area will be denoted by 4 pi r square. Okay, area of the drop will be denoted by 4 pi r square into delta r. Can you know why we write here this step? This is the value of F. Why we write this? Now as per the definition of pressure, pressure is equal to force upon area. So this is not only pressure, this is axis of pressure, and axis of pressure is Pi minus Po. You get it clear? So this is equal to the axis of force divided by area, and area will be denoted by A. Okay, initial area, that is A1. Now this value of force is equal to axis pressure Pi minus Po into area, and area will be denoted by 4 pi r square. The same term will be given here. Okay, the same term will be given here. Now let's see the next. Call equation number 5. This is our equation number 5. So this equation number 5 is also indicate the work, and equation number 4 is also indicate the total work. So can I comparing the equation for both represents work done? So comparing equation 4 and 5. So what we get when we comparing these two equations? So comparing equation 4 and 5. When we comparing equation 4 and 5, the equation 4 is T into 8 pi r into delta r. Okay, and this is equal to, this equation is Pi minus Po into 4 pi r square into delta r. So what is the value of axis of pressure? Okay, what is the value of axis of pressure? Now the axis of pressure Pi minus Po is equal to what? Now equal to T into 8 pi r into delta r whole divided by, what is remaining here? Remaining here 4 pi r square into delta R. So which factors are cancelled? Let's see here. Now here pi get cancelled, delta R will be cancelled, 1 R will be cancelled, 4 1s are 4, 4 2s are 8. What is remaining for axis of pressure? Pi minus Po is equal to what is remaining? Now there 2T will be remaining, this 2 and T, and divided by only R. So this is the value of axis of pressure. Okay, this is the value of axis of pressure. Pi minus Po is equal to 2T upon R. Axis of pressure means change in pressure, the inside pressure and outside pressure. If the pressure difference between two is 2T upon R, so then after the drop will be produces. This is the expression for the formation of drop. When the drop produces, now when the inside pressure and outside pressure, their pressure difference Pi minus Po is equal to 2T upon R, so then after the drop will be produces. This is the condition. This condition is very important, the expression for formation of drop. You get it clear? And this equation is also called the Laplace's law of spherical membrane. You get it clear? So after that we have discussed about bubble. What is the expression for the formation of bubble? But then before, the some terms I can rub this. Okay. Now imagine that this is a bubble. So what is the difference between drop and bubble? So between the drop, it will completely fill with liquid. There only one side is contact in air. But according to bubble, so inside the bubble is also air produces and outside the bubble is also air produces. It means there are two surfaces is contact in air. This is very easy difference between drop and bubble. Get it clear? Now the initial surface area of the bubble will be same, that is 4 pi r square. And due to the axis of pressure, now inside surface is the concave, so inside pressure will be high, so outside will be convex, so outside pressure will be low, so pressure change, that is axis of pressure. Get it clear? Now due to this, the final surface area we get, what is the final surface area? So A2 is equal to, okay, this A2 is equal to 4 pi r square plus 8 pi r into delta r. Same terms are there. So how amount of area will be changed? Now dA is equal to A2 minus A1, final area minus initial area. So we get the change in surface area dA is equal to 8 pi r into delta r. But this equation we can write here, the total change in area dA is equal to 2 times the 8 pi r into delta r. We write here 2 extra. Why? Because the because bubble has two surfaces is contact in air. And due to this, the 2 times their pressure will be changed inside and outside. You get it clear? There are two surfaces is contact in air. This is the difference. So that's why we can write here 2. Get it clear? So it means that finally we get the change in surface area dA is equal to 8 to the 16 pi r into delta r. So this is the change in surface area according to bubble. This is very small difference between two. So after that, if the surface area changed, so work has to be done, and this work done as per the relationship between surface energy and surface tension, dW is equal to T into dA. So only we write here dW is equal to T into 8, not what 8, this is 16. After that we find out 16 pi r into delta r according to bubble. This is very small and simple change. Get it clear? But as per the definition of work done, force into displacement. So this axis of force means what? Axis of pressure into area, and the change in area will be denoted by delta R. So comparing these two equations. When we comparing these two equations, so we get now here T into 16 pi r into delta r, and this is equal to now there Pi minus Po into 4 pi r square into delta r. Clear? Now after that the axis of pressure Pi minus Po is equal to, so this is T into 16 pi r into delta r whole divided by what is remaining 4 pi r square into delta r. So which terms are neglected? Now here pi will be cancelled, delta r will be cancelled, 1 r will be cancelled, 4 1s are 4, 4 4s are 16. So it means we get axis of pressure Pi minus Po is equal to, what is remaining? 4, and this is T. So 4T and divided by R. So 4T divided by R. So this is the expression for the formation of bubble. You get it clear? So 2T upon R, this is the expression for the formation of drop, and 4T upon R, this is the expression for the formation of bubble. If the pressure difference between inside and outside of the drop is 2T upon R, so the drop will be produces, and if the pressure difference is 4T upon R, so bubble will be produces. You get it clear? So that's why these expressions are very, very important as per board examination and as per the competitive exams. Get it clear? So this is the excess pressure and this is the expression for the formation of drop and bubble. So can you get this? Okay. Now we can stop here.